Hello and welcome to this video about using water displacement to collect a gas. Collecting gases is difficult. It's incredibly tough because we cannot see or touch these substances. However, if we force the gas into a jar of water, causing the water to be pushed out, we will leave a jar of gas behind. By doing so, it is really important that we understand that the gas cannot dissolve into the water. If the gas were to dissolve into the water, this experiment would be useless. We need a gas that is insoluble or does not dissolve into the water. In this particular lab, you are going to create hydrogen gas, represented by the symbol H2. Hydrogen being diatomic, so you need the 2 there. You're going to create the H2 gas by reacting zinc, which has the symbol Zn from the periodic table, with hydrochloric acid, which has the symbol HCl. By reacting the zinc and hydrochloric acid together, we will produce that hydrogen gas. We will then test its properties through various tests, which I will talk about later in this video. Let's take a look at the setup for this a little bit more closely. First thing we need to look at is our Erlenmeyer flask, which will serve as our reaction vessel. The reaction vessel is where we will place the zinc and the hydrochloric acid. The zinc will be placed into the bottom of the flask at first, and the hydrochloric acid will be poured into the top up here. The tube that we pour the hydrochloric acid in will look like this. It looks kind of like a funnel with a straw attached to it. This is called the thistle tube because it looks like a thistle, the flower. The hydrochloric acid will be poured down, and this will react with the zinc, producing our hydrogen gas. This hydrogen gas will then be forced through this pipe into a trough of water. One important note that is really important to notice is this level of the liquid in here. The HCl must, whoops, almost forgot my L there. The HCl must come above the bottom of that thistle tube. That is important. The reason for that is without that, the H2 will escape through the top of the thistle tube instead of the hose. Okay? That is very important. Next to this, we have this moist paper towel. The purpose of this is to ensure that this flask doesn't get too hot. So this wet paper towel will be wrapped around this flask, A, to keep it from overheating, and B, if this flask were to become cracked or rupture, it will keep everything kind of contained within itself. We've never had a flask rupture, at least not as long as I've been teaching, but better safe than sorry. So like I said, the H2 will be made in this reaction vessel and then will flow through this tube into the water trough, which will look like a tiny bathtub. It's drawn here. The water trough will have your jars in it, and they will be filled with water, as you can see in here. As the hydrogen bubbles up, it will push the water down and out of this bottle, filling each of your bottles with hydrogen gas. So over time, the water will be pushed out, and this will become full of gas. The water level in the tub will rise, and excess water will be pushed out the side. It is very important that the hose on the other side of the water trough lead to the sink. The reason for that is when this water comes gushing out, it needs to go down the drain and not over the countertop. So that's the important setup. Again, to give you a general idea of how this will work, one last time as an overview, the hydrogen gas will be produced here in the reaction vessel. It will be piped through the tube and into your jar. The excess water then will be pushed out of the jar and into the sink. And by the end of the experiment, you will have 4 jars completely filled with hydrogen gas, and you will be able to test them. This image is a really nice image to show you exactly how the water trough will look in real life. The hydrogen gas gets pumped through here into the bottom of this bottle. You can see the gas pushing the water out. As this water level rises, you can see here out the other side, that is where the excess water will be pushed. So you will be collecting, just like in this photo, 4 bottles of gas using this, and you will be given a glass plate which will allow you to cap the bottles and lift them in and out of the tub. And that will help you with that. You will complete 4 tests with your hydrogen gas. The important thing is to remember you need to leave your bottles mouth side down on your table until you're ready to test. If you tip them or tilt them, you might not get what you want. The 4 tests are as follows. First, you will leave 1 bottle mouth side up, as illustrated here in diagram number 1. You will wait 60 seconds and you will take a flaming splint, not a match, but a splint or wood stick like we used for the flame test lab, and you will place that near the mouth of the first bottle. The second test is you will take a mouth side down bottle and you will place it on 2 pencils like in the image right over here, so that the pencils go on the bottom right there and there, propping your jar about an inch or 1/4 of an inch, I don't really know inches, but about 1 centimeter off the tabletop. That will allow you just enough room to take the flaming splint and place it underneath, which you can see right there. To zoom back out again, the third test, you're going to do something similar, except instead of having it on pencils, you are going to lift the bottle directly into the air, and you will take the flaming splint and put it underneath. The last test, which is the trickiest test to think about, is what we call the stacked bottles. The stacked bottles are, like I said, a little bit trickier, and I will outline those down here in example number 4. So in doing so, what you will do is you will take a full bottle of hydrogen gas right here, and you will place it on top of a bottle of air. You will let them sit with each other for 3 minutes and let them hang out. After 3 minutes, you will cover the bottom bottle and you will immediately light the top one. After you observe, you will uncover the bottom one and you will light that one. So again, that one's typically the one that people struggle with the most, because you have 2 bottles. You need to make sure that the top one has the hydrogen in it. You need to let them sit together, and then you light the top one and the bottom one individually. The last important thing to note here is cleanup. We never want zinc in the sink. That is important because it will clog up our pipes. Rather, what you will do is you will take the reaction waste, you will add a little bit of water into it, and it will go into a bucket in the hood. If you follow all these procedures, this is a really fun lab. It is incredibly safe, it is incredibly cool, and hopefully you will come out of it with a better understanding of the properties of hydrogen gas. Thank you for watching. In order to complete this lab, you will need to turn in the proof that you took these notes, and I will see you next time.